We're going to do some varied exponent problems. And there's some things, especially when we deal with numbers, where it gets tricky. So one is A versus B. Suppose I have the number -2 to the second power. When we're dealing with numbers, this 2 here is telling us we're going to be multiplying that twice. That's what the exponent means. -2 times -2, and negative times negative is +4. But suppose I write not the -2 in parentheses, but I write -2 squared. This problem is really like saying -1 times 2 squared. So by order of operations, we do the square first, 2 times 2, then times the -1. So it's -1 times 2 times 2. So this answer would be -4. I'm going to do another few. Let's say I have -2 to the -3 versus -2 to the -3. We're going to do two different ones. They look very different except they have a parentheses. So we'll see what happens to the result. So for this one, it's really doing -1 times 2 to the -3. But I have to remember what the negative exponent is. That's a reciprocal. So this is -1 times 1 over 2 cubed, which is -1 times 1 over 2 cubed is 2 times 2 times 2, which is 4 times 2 is 8. So this answer is -1/8. So here, this -3 tells me I'm going to write this as 1 over -2 to the third, because that's the definition of negative exponents. It goes down below as a reciprocal and becomes a positive. Now, to work this out, it's 1 over -2 raised to the third power means I'm going to write it 3 times. So it's -2, -2, -2. So it's 1 over -2 times 2 is +4. +4 times -2 is -8. But one thing in algebra is we always like the negative sign either in front of the fraction or on top. So we write it as -1/8. And you will notice that both of those did give the same answer. Now looking at the one we just did, I want to look at, I had -2 to the -3, and it was 1 over -2 to the third. But I know that 3 negatives will be a negative, so I'll get a negative answer. But what if it was -2 to the -14th? That's going to be 1 over -2 to the 14th. But this is an even number of negatives, so we know this will be a positive answer. So now we'll do an example that incorporates some of these ideas. First, we'll start with, suppose I give you 3a to the -5 b squared over 12a to the third b to the -4, and we're taking all this to the -1 power. By order of operations, I have parentheses, and then I have an exponent. So we do the parentheses first. So first step, this 3 divides into itself once and into this 4. And now, within that parentheses, I'm going to use my gopher shortcut to get rid of those negative exponents. This then becomes, I have a 1. I don't need to put it. I have a to the I've got the 4 down here. I've got a to the -5. That goes below as a to the 5th. b squared stays on top. I had an a cubed on the bottom. b to the -4, the gopher idea, something negative below, it goes above as b to the 4th. And all of this is to the -1 power. We don't want two bases because it means we can do a rule of exponents, and we don't want two a's. So this gets written as b2, b4, we're adding exponents, it's b6. 4 is a number, it just stays. a5, a3, we're adding those exponents, it's a8. and the whole thing is to the negative 1 power. Okay, so now if I went through all the steps, this would become b to the negative 6. Then this is 4 to the 1. So you're actually putting the negative 1 as the exponent here. So it's 4 to the negative 1. A to the 8 times negative 1 is negative 8. And now, of course, thinking of that gopher shortcut that I told you, the b to the negative 6, something negative above, it becomes positive. 4 to the negative 1, it becomes positive by going above. It's 4 to the 1, which is 4. A to the negative 8, it becomes positive. And that becomes your answer for that. So we'll do our next example, and it will be a little bit harder problem. Suppose I had 2a to the negative 3, b to the negative 2, over 5a4, b raised, the whole thing raised to the negative 3 power. By doing the parentheses first, because we want to simplify as much as we can, we see this is going to come down and this one will come down. So doing the parentheses, we haven't messed with the negative 3 exponent at all. We have the 2 on top. We have 5 on the bottom. The a to the negative 3 comes down as a cubed. The b to the negative 2 comes down as b squared. And the b, which was there, stays. We've now done as much as we haven't actually. We can now combine those b's. So we have 2 over 5. We've got the a cubed, and I forgot, you guys, the a to the 4th. Almost forgot that. We need that a to the 4th. So we have a cubed and a to the 4th, which is a to the 7th. We have b squared and b, but this is like b to the 1, so it's b cubed, all to the negative 3 power. To get to this step, I put together the a cubed and the a to the 4th, and it was a to the 7th, the b squared and the b cubed. Now in my next step, I'm going to pull the negative 1 through, multiplying exponents, but 2 and 5 don't have exponents, so I have to give them the exponent of 1. So now I'm going to multiply the exponent, and I am going to get 2 to the negative 3 on top, and then the negative 3 here, 5 to the negative 3, negative 3 times 7, a to the negative 21, and b to the negative 9. Now we're almost finished, but we're going to use that gopher shortcut that I call. So because all of these are negative, they all switch location. The 2 to the negative 3 goes down and becomes positive, and 5 to the negative 3 goes on top, becomes positive. A to the negative 21 goes on top. B to the negative 9 goes on top. And we're almost finished, except with numbers we like to write them out. So we actually have to multiply them out. So this one, 5 cubed, we have to go 5 times 5 times 5, A21, B9. And for 2 cubed, it's 2 times 2 times 2. So 5 times 5, 25 times 5, our final answer is 125, A21, B9 over 2 times 2, 4 times 2, 8. And that becomes our solution.